In this video, we're going to look at another example of solving simultaneous equations using the substitution method. So this one's a slightly harder example compared to example 1. Let's go through it. Solve simultaneously the equations y equals 2x minus 1 and 4x minus 3y plus 5 equals 0. Now, I guess the end result of applying the substitution method is very similar to the elimination method. We have two equations, two different types of pronumerals. We have a y and an x in both of these equations. So we need to eliminate one of them. Now, equation number 1, I might just label that. Equation number 1 already has y as a subject of the formula. Equation number 2 just sort of looks like general form, a general form linear equation, sort of everything on one side. Now, equation number 1 lends itself very nicely to substitution. Since y is already the subject of the formula, we could take, I guess, equation number 1 and substitute the y in equation number 2. So this y here, we're going to eliminate this by replacing the y in equation number 2 with the right-hand side of equation number 1. Since y and 2x minus 1 are the same value, how do I know that? Well, there's an equal sign. I could, in fact, take the letter y or the pronumeral y and substitute it out, and in the brackets put 2x minus 1 instead, since they are the same value, or they evaluate to the same thing in the end. I could also eliminate the x, but it's a lot harder. I'd have to make x the subject of the formula in one of these two equations. So since it's already in a form where I could eliminate the y sort of very quickly and quite efficiently, let's just leave it at that. So from equation number 2, okay, we're going to eliminate the y, create one equation in x, solve for x, substitute the x back into probably equation number 1, it's probably the most convenient, and then find the value of y. So 4x minus 3. Now, very important to use the brackets here. Now, instead of writing 3y, from equation number 1, the y and 2x minus 1, left-hand side and right-hand side, are both equivalent to each other. So I don't want an equation that uses x and y. Let's just use the one type of pronumeral. It just makes life a lot easier for us. So I'm going to replace the y, substitute 2x minus 1 for the pronumeral y. And let's write the rest of equation number 2. So that's plus 5 equals 0. Now I have an equation, one equation with one type of pronumeral. And hopefully that should solve nicely. So let's do that. Expand the brackets. So minus 6x plus 3 plus 5 equals 0. Okay, so 4x minus 6x, I've got negative 2x is equal to negative 8. And therefore x is equal to 4. Now we can use equation number 1 to find the value of y when x equals 4. So from equation number 1, y is equal to 2 multiplied by 4 minus 1. So therefore y is equal to 7. Okay, so therefore the solution to this equation is x equals 4, y equals 7, or we could write it in coordinate form or coordinate format. That's 4, 7. Okay. Let's have a look at this graphically, and we'll use the graphing calculator again. Okay, so here we are. Hopefully I've set the equations up already. Okay, to graph both of these equations. Now, if you look at the first equation, I'll just zoom in there so you can see what I'm doing. Okay, y equals 4 on 3x plus 5 on 3. I'll just bring this back. Okay, in order to be able to graph these two equations, it needs to be in y equals mx plus c form, so that's gradient intercept form. So the first equation already is in gradient intercept form, gradient of 2, y-intercept of negative 1. The second equation, though, is in what we call general form. We want it in gradient intercept form, which means that I have to make y the subject of the formula. That's not the purpose of this video. Just, I guess, accept that, oops, I think I've just deleted that. I might just put that in there again. So that's y is equal to, okay, I'll just type that in again. Okay, and that's going to be 4 on 3. It's a bit easier if I did that. Yep, 4 on 3x plus 5 on 3. Yep, Okay, so that's in gradient intercept form. And the other equation, the first equation is already in gradient intercept form. So we can graph those two. Let's have a look and see if we end up with the same result graphically. So if you're asked to graph both of these equations or solve graphically, obviously you need to graph them to scale and then check to see, obviously, if the solution makes sense. So that'll be the point of intersection there. Let's have a look, see if I can maybe pin zoom. Does that work? Yep, should do. Yep, maybe a little bit more. Okay, wait for the calculator to keep up. There we go. So we can see there that it looks like 4,7 is the solution graphically as well. So it's the beauty of these calculators that has a graphical solver, which is kind of nice. So there you go. And 4,7 is the solution there.